Welcome, everyone. Seeing people trickle in, and I'm going to get started a little bit slowly here. My name is Nathan Heston. I'm an energy solutions trainer at Briggs & Stratton, and I'm joined by my colleague today, John Ross-Cromer. John, good morning.
Hey, how's it going?
And on the call with us as well is Daniel Moyer. Daniel is going to be monitoring the questions and answers for us. And so if you do have questions, feel free to use that Q&A feature of the webinar. We'll be taking questions throughout. Sometimes Daniel might interrupt us and ask us to answer questions as we go through the slide deck. So we're excited to be talking today about the latest battery that SimpliPhi has produced. And this battery is specifically designed for the Sol-Ark 15k inverter. We're going to be talking about how the pairing is really a good fit with the 15k, and we'll talk about why that is. This is a NABCEP certified training, so if you're here for those continuing education credits, please stay through to the end. We'll put our email up at the end, and then you can email us and let us know how your name should appear on your certificate, and we'll get that generated. So, John, thanks for joining me. Let's go ahead and jump into it. So Briggs & Stratton has been around for 115 years. You probably know them as a small engines manufacturer, a generator manufacturer, and a couple of years ago they acquired SimpliPhi Power that produces batteries in Oxnard, California. SimpliPhi Power has been around since 2010, and now Briggs & Stratton is able to offer a complete lineup of both batteries and generators, and really offer some pretty good backup solutions for your home. And coupling those together with Sol-Ark inverters gives us some pretty versatile offerings, and we're going to talk about those today. We have a full lineup of different batteries. We have batteries from our Phi battery, our non-communicating battery, which is a fairly popular option still. It's been a workhorse in the field for many years. We've got many batteries out there outliving their warranty, still providing power for customers from our early days. We've introduced a few years ago the SimpliPhi battery that you see, and that's a communicating battery. Of course, has closed loop communications with Sol-Ark inverters. And then more recently, we introduced the 4.9 kilowatt hour outdoor rated battery. And it has a similar BMS communication protocol that also matches up with Sol-Ark. But we're really going to be highlighting today the battery on the right. This is the latest battery from SimpliPhi Power, Briggs & Stratton. It's a stackable battery, and this stackable battery can be either floor or wall mounted. We've got higher output, and again, it's perfectly suited for the Sol-Ark 15K. So here's what that battery looks like on a wall with a Sol-Ark 15K inverter, outdoor rated battery, outdoor rated inverter, a very nice pairing, and we'll talk about all of the advantages to those Sol-Ark 15K inverters, which is what's making them so popular. I do want to point out that though the SimpliPhi and the Phi batteries are not outdoor rated, we do have NEMA 3R enclosures, and these enclosures have the ability to offer heating that can be built into the BMS and directly heat the batteries in cold weather environments. These cabinets can also be utilized to provide an access system, and this is a complete, almost plug-and-play system that we can integrate with Sol-Ark inverters. And you see that on the right paired with an 8K Sol-Ark and our communicating batteries there. It's a 9540 certified system, and we can scale these up to 137 kilowatt hours, so fairly large systems. Also want to mention, as we get started, Briggs & Stratton Energy Solutions produces a full lineup of generators, and we're looking at our air-cooled generators here. The Power Protect line features NG Max, and there's no derating with NG Max. We're able to tweak our settings on our fuel intake to provide the same amount of power with natural gas that you can get with liquid propane. And I'm going to switch over and let John talk a little bit about Sol-Ark and the history of Sol-Ark as well.
All right. Hey everyone. So you're probably familiar with Sol-Ark. If you're familiar with SimpliPhi, the biggest claim to fame that Sol-Ark has is we have the most amount of field experience with transformerless hybrid inverters out of anyone in the U.S. market. So we launched the 8K back in 2018. We've dramatically expanded the product line into whole home backup with the 15K. We've gone into commercial three-phase systems with the 30K and 60K. And then on the commercial end, but not on the residential end, we do have a high voltage battery line for commercial only. So a very wide product range that kind of spans all of your applications, and we'll go into those briefly. Just looking at our timeline, the actual company goes back earlier than 2018 when we were kind of exploring off-grid systems and portable power systems. And that kind of got Sol-Ark focused on building all-in-one systems robust enough to support the off-grid market. We launched with the 8K2P in 2018, the intent being to simplify installation, include as much of the system as we can within the inverter, and that's only been expanded upon in 2019. We increased the size of the inverter, significantly increased its DC processing capability, although on the 12K, that is the solar processing capability. It's only a 9K output. If we could go back in time, we would relabel it a 9K inverter because that, while we were proud of the DC bonus, ultimately we moved away from that nomenclature when we launched the 15K. So the 12K was really nice. It included all the breakers. We started establishing relationships with financing partners, so it's very easy. Your favorite financing options we can get, or we are already on the list for. The exception being Sonova. So if you are needing Sonova financing, please bug them about our product. We are in those discussions, but the more field and grassroots support, the better. 2020, we continued to expand our battery relationships, although that's contracted a bit with the advent of 9540 listing requirements. So now we tend to work closely with a handful of battery partners rather than try and support the entirety of the industry. 2021, we moved into a headquarters facility, but we quickly outgrew it. So in 2023, we moved into a brand new headquarters. It's 300,000 square feet. It's a 500-person office building. Not quite there yet in terms of employee count, but that's kind of the goal and level of commitment to U.S. presence and U.S. jobs that we have. We have Latin America inverter product lines. If you install in that market, you should interface with our LATAM team. And then this year is really the advent of our commercial battery line.
So, John, we've got a question from Will, and I've got the same question, to be honest, because I'm interested in this product just for my own use. Where do we stand on the optimizer launch?
Yeah, the optimizers will remain a third-party product under the intelligent product line. So we're not abandoning the optimizers, but we're not bringing them in-house. They'll remain a third-party option, just like AP Systems, Tigo, and NEP. Our residential hybrid inverter series, the 15K, is the most powerful residential hybrid inverter on the market. So there's a question, do the batteries work with the Briggs and Stratton inverters? And I'm sure the answer is yes. But when it comes to whole home backup reliability, Sol-Ark has the biggest and the most experienced inverter on the market. And when it comes to reliability, given those conditions, that's the number one selling point here. So it's a well-supported, well-tested, well-field experienced system. There's some advantages of all-in-one that enable a true seamless backup or seamless transfer. It is a modular architecture, so you can build very large systems with it. And then it's net metering 3.0 and VPP ready. What I liked about the built-in controls with the Sol-Ark is we did not have to change anything for these systems to be programmed for California net metering 3.0 rate structures. Um, you know, because our time of use controller was already robust enough to handle that input. And we'll get into some more advantages in a few slides. The Sol-Ark enables you to keep your existing rooftop solar strategy if you like microinverters. However, you can save a little bit of money going with DC optimizers or even string level rapid shutdown with Midnight. Um, in terms of being able to be utilize DC coupling and maintain rapid shutdown compliance. We kind of refer to it as the Swiss Army knife of inverters, or at least our public does, because there are enough features to accommodate a variety of design challenges. One of the items is an additional GEN port, which is very useful for plugging in an EV charger or a generator. And then we have commercial options as well. So, you know, your residential and commercial fleet management can be simplified. Just looking at what makes a Sol-Ark a Sol-Ark, not only is it a hybrid inverter in the sense that it does batteries and solar, but we also include the grid controls. So that's where most of our competition, at least the ones who haven't directly ripped off our product design, fall short, is that they require an additional energy panel or microgrid disconnect, or whatever it's called. It's additional panel that you have to put in ahead of the inverter system to do the grid management. That 200 amp pass through is built into our inverter. You just land the grid directly onto the inverter and then wire it up to the sub panel.
So John, I have a
So
question on that. When you
sure.
are landing the grid, you can either come through fuses or a service entrance rated breaker. And I've heard that you recommend coming through even a bypass switch for potential a manual bypass switch. What's your preferred method for landing from the grid on the 15K?
Yeah, well, there's a variety of options. I'd say the most popular option is to simply get a 200 amp breaker in a breaker box. You know, that's your utility required external system disconnect, and it's the lowest cost way to do it. We do have on the 15K, we have a breaker for the load side of the inverter, but you need to provide a disconnect on the grid side of the inverter. Now, beyond that, there are a couple of strategies you can utilize. Instead of doing a 200 amp breaker, you could do a manual bypass, although you would still have to figure out overcurrent protection of that bypass. I kind of prefer, you know, there are low budget ways you can do it too. You can double lug off the grid side of the system and put in a 40 amp generator interlock kit, which most service panel companies now make pre-configured sub panels for those interlock kits. And that would give you temporary service power if you needed to take the system offline for servicing without the cost of a bypass switch. So we talk about a lot of those system configurations and design considerations in our training portal. If contractors would like more design classes, I'd say we have a number of them at, if you go to the Sol-Ark website, go under our training session, you'll find our training portal and be able to get to them that way.
So thanks, John. We're gonna start right here at the beginning, and we realize that to most people they understand what an ESS is, right? Most of you are also common with grid-tied inverters. And so what is an energy storage system? Typically, an energy storage system has a high-quality inverter like a Sol-Ark 15k that can process and control the flow of energy. If you're a generator person, you can almost think of the inverter as a transfer switch, right? Management of that power. So bringing in generator power, connecting that to loads, bringing in solar power. Bringing in battery power. Of course, we call it an inverter because it does need to transform the DC power coming from solar and coming from batteries into AC power. But that really the center of your system, the hub of your system is an inverter like the 15K. And of course, for the battery storage side of things, you have to have a high quality battery, a battery that is capable of longevity, a battery that is capable of communicating with the inverter. And so that side of things, we're recommending batteries like our SimpliPhi batteries. So what do we mean by whole home backup? The title of today's talk is Whole Home Backup, featuring the Sol-Ark 15K and SimpliPhi batteries. Well, there are many different ways to do load backup, right? And one example of that is just to back up part of the home. If you have an inverter that's not capable of bringing 200 amps through it, like the Sol-Ark is, you know, the Briggs & Stratton inverter is only capable of bringing 40 amps through. And so you can't back up your entire load panel with that, because 40 amps is not enough power to back up all of your loads, to power all of your loads, or even to just pass through that power. So you would have to install an extra loads panel. And that extra loads panel, in the event of a grid down situation, will isolate itself. So the inverter will isolate itself from the main loads panel. And so you're only backing up a portion of the home. If you do have a battery, right, then that battery is able to keep that, that AC signal alive. If we have a grid forming inverter like the small Briggs & Stratton 6K inverter there, and then you could back up the core loads to the house. Maybe you want to back up the internet. Maybe you would like to back up your lights, etc. Let's contrast that with whole home backup. What do we mean by whole home backup? So the Sol-Ark 15K is shown there on the right side of the screen. And it's connected to the grid as well. What happens in a grid down situation here? Well, first off, notice that there's only one loads panel there. It's just that main panel. The entire main panel is going to be supplied by power that is run through the Sol-Ark 15K inverter. Of course, you have a battery as well to make it an energy storage system. And then that battery will power, in the event of a grid down situation, that battery will power the entire loads panel. Now, we should keep in mind the Sol-Ark 15K is capable of pulling 200 amps, you know, from the grid and passing that through to the main loads panel. But when operating off of batteries and solar, we're much more limited, right? Off of batteries alone, we're at 60 amps at 240 AC. So keep in mind, when we're saying whole home backup, we don't necessarily mean that there's enough power to run your entire home if you're really going to slam your home with 200 amps. But for most homes, the Sol-Ark 15K, a single Sol-Ark 15K, is capable of backing up the average amount of use. It doesn't mean you can't overload it, but it does have surge built into it, etc. So this is what we're talking about when we're saying whole home backup. We have all of the loads coming off that inverter. And John, I'll give you a few minutes if you don't mind talking us through the Sol-Ark 15K.
Sure. The 15K is our flagship inverter. We do have, for residential, we do have other inverters, but you know, even more than 9 times out of 10, it's the 15K being installed because of that whole home backup capability. And the reason is, and you know, that one line diagram for competitor systems is not completely representative of what a one line diagram would be, but the point is illustrated nonetheless. When you have multiple inverters, when you have multiple batteries, multiple battery inverters, when you have a whole home panel and a backup panel, all of that stuff has to be combined together. So just remember, it's not just the cost of the inverter itself. It's the cost of all of that additional labor. And then it's the cost of needing to support the product throughout its warranty period as well. But just looking at the cost savings related to the project site, you know, the combining work of all of these parts go away when you get to the 15K. And you know, load control is sometimes perceived as necessary to stay within the output limits of the inverter system. But what I would say is, if that's a concern, then you should be starting with the largest inverter possible, which the 15K is. It does 15K with solar, 12K AC without solar.
And
Um,
what you mentioned about it, John, is what I liked so much about installing a 15K. You don't have so many parts and pieces, right? It's a quick, easy install, and yet you have a lot of power to integrate multiple things, even smart loads, right? Two-wire start with generators we'll get into. We've got a couple of questions, and I wanted to ask them to you. What about using a smart panel like Span or Lumen? Will it work with these?
Well, it will. It kind of works in parallel or independent of it. But what I think a lot of installers are missing is the functionality of the gen port on the Sol-Ark, which is, if you're not using the gen port for a generator, there's a lot of areas in California that are not generator friendly. If you're doing a grid tied system and you're not using the gen port for a generator, it is possible to tie in a sub panel, and that will give you a state of charge based load sheddable sub panel. And at that point, I think that a few years ago you did not see device level load control on the market, but now there are products out there like AOTech and Migro and even GE from time to time, selling Wi-Fi smart load control, 50 amp for 50 amp devices that could turn a water heater on and off, or turn an air conditioner on and off, and they're $200 per device. So if I were doing a system design and I wanted to implement load control, what I would do is I would put all of the heavies on a sub panel, tie the sub panel into the gen port, and then put half of those circuits on device level on off switches. Now, I don't think it's very responsible for load control to just turn a bunch of electrical devices on and off. Imagine standing in front of your sub panel and trying to implement load control by flicking a lot of breakers. That's not very elegant. And load control, in the future is easily going to be like, oh, your air conditioning system recognizes when there's a power outage and adjusts the thermostat settings rather than doing a hard slam on and off. So when it comes to like the what you get with the Sol-Ark, if you're not using the gen port for a generator, consider putting in a sub panel, putting a couple of those circuits on device level load control, and now you have a very robust load control circuit that you can, during a power outage, you can pull open your load control app, turn off your heavies, and then if the battery drops down to a predetermined state of charge, you can shed all of your heavies and be able to coast through the night with things like lights and garage door access and things like that.
I think we're
So
going to get to some of those wiring diagrams as well, and maybe we can revisit those questions. We've
yeah,
got a customer that says, I've got a whole home backup system installed by another supplier with AC microinverters and 20 kilowatt hours of battery storage. Now I'm finding out that I must get a very large generator, 22 kilowatts or more capacity, to ensure compatibility. When Sol-Ark does whole home backup, what are the requirements for generator size and compatibility?
yeah. So the generator port on the Sol-Ark is throttled to 19 kilowatts, but you can land a 22 or 24 kilowatt generator on that. You can also land a generator on the grid side using an external transfer switch. I would strongly recommend going through the Sol-Ark training portal when designing with generators, because they are tricky. You can't do the things that you imagine you can do with a generator and microinverters and time of use metering and grid selling all at the same time so elegantly, you might have to identify a way to throttle that back, such as using the generator's native controls to only run the generator during non-solar hours if you want to have it all. If you want to have microinverters and use the gen port for something else and put the generator on its own transfer switch. So, with when you want to design with generators, I would strongly say that that is a reason to either use the gen port on the Sol-Ark or to go with DC coupling rather than microinverters. So,
Absolutely agree on DC coupling. And I would say on the generator side of things, oftentimes when your generator comes on, you're also charging batteries as well as supporting loads. So if you reduce that charge rate of your batteries from pulling on the generator, you might not need such a big generator. You mentioned needing a 22 kilowatt generator just to stay on. But you can do some clever things with a Sol-Ark to limit that. Do you want to talk a little bit about Sol-Ark Lite, John?
yeah, the other Sol-Ark inverters for the residential level are don't get enough attention now that we have the 15K and everyone wants to do whole home backup. Um, I would not neglect the non-backup market. It seems to be that the non-backup solar battery market is larger than the backup solar battery market in residential solar in California because of extreme time of use rate structures and budgets and affordability. That market was an extreme net metered market, and now that's gone away and they're replacing it with solar and batteries. You can shave a little bit of table stakes off of the buying cost by going with a cheaper inverter and abandoning the backup capability of the system, maybe adding it down the road. So we do have a low-cost Sol-Ark Lite inverter. It is not capable of 120, 240. It's only capable of 240. Advanced users might be able to figure out ways to expand that. But it's also a good inverter if you want to, say, expand an existing system. If you have older batteries and you want to expand the battery bank, you can't just, even if they're the same make and model, you can't always put old batteries with new batteries and have good product life. So the Sol-Ark Lite can run in parallel and do demand management, thereby expanding a bank. And then sometimes the 12K is a better choice than the 15K in niche markets like California, where you might have a meter-based combo and you don't need the full backup capability. It just has more breakers included. So an advanced Sol-Ark user might figure out the right way to use the 12K, but most Sol-Ark installers are just going with a 15K today, and then maybe considering the 8K Lite for your non-backup economic focused projects.
Thanks, John. So this is the battery we're going to be highlighting today. This is the latest SimpliPhi battery. They're stackable 6.6 kilowatt hour batteries. And those batteries, once you stack them into a stack of 3, is 20 kilowatt hours, which is the limit for a single standalone ESS. This battery is using LFP chemistry, as I mentioned, for superior safety, longevity, 4,500 cycles at 0.75 C. You're going to see here in a minute that we're able to run this battery a lot harder, a lot faster than some of our previous offerings. If we slow things down a little bit, if we're doing only 80% depth of discharge, we're getting over 6,000 cycles here, and we say 6,000 plus because this is based on rapid charge discharge. We expect that the average customer is not going to be continuously charging at 0.75 C, which means a charge cycle in an hour and 20 minutes, charge and discharge in an hour and 20 minutes. So here's what I was getting at with the overall power capabilities of these batteries. In a single module, a single stack, this battery can output at 1 C. That means discharge, a full discharge in a single hour. If we stack these batteries up, we have to be a little bit more careful about balancing, making sure that the bottom batteries is doing as much work as the top battery. And so we scale it back a little bit to 0.8 C, but just to stack 2 of these batteries, 13.3 kilowatt hour stack can output over 10.5 kilowatts of power. And then a 3 stack of these batteries, a triple stack like this, can output 14 continuous kilowatts of power. And as John mentioned earlier, the Sol-Ark 15k from battery alone is capable of 12 kilowatts of continuous power. So a single stack of 3 of these batteries can offer you the full capabilities of Sol-Ark 15k in terms of power output. But obviously, the amount of time, the backup time you get will depend on how much overall capacity you have and how quickly you're using that power. If you're backing up the whole home, you might have a lot more loads to back up, and you might want more than a single stack. And this battery can be stacked up to 6 of these units in parallel. The components that you need to do this battery, so this battery can be wall mounted or floor mounted. The modules themselves are coming in at a very strong price point, 6.65 kilowatt hour modules, and a controller box to go on the top. So each stack will consist of a floor mount or a wall mount, battery modules, and then a controller box. And the gateway itself will be used for firmware updates and individual monitoring of battery modules. John, let's jump into looking at a single line diagram here for a Sol-Ark 15k. This is a basic example in which we've got a single stack of 3 of these 6.6 batteries to get 20 kilowatt hours. This is a DC coupled example. We've got rapid shutdowns to be compliant for a roof mount array. We're coming through a disconnect that, of course, doesn't have to be a fuse. That could be a breaker disconnect, as John was saying, is the most economical way to disconnect. Got the rapid shutdown button there, and that will kill the signal to those. I'm not showing a transmitter there, but that would kill the signal to those rapid shutdown modules. So notice you're coming out of the meter, coming into the Sol-Ark, and then you're backing up the entire loads panel. Scott asks, does the new 6.65 battery use cylindrical cells, prismatic cells, or pouch cells? We're using this, the first time we're doing this, we're using blade style pouch cells with this battery. And we're packing them pretty tightly as well. So we've got a pretty compact battery overall in this design. It's about 6 inches deep, about 19 inches tall, and about 2.5 feet wide, a little over 28 inches wide. Let's look at another example here. This is an example with an off-grid system. And in an off-grid system, you would not be utilizing the generator port. So John mentioned earlier, that the gen port on the Sol-Ark is limited to 19 kilowatts. But in an off-grid situation, we would recommend that you would use the grid port to bring in that generator. So you could bring in a 26K Power Protect Briggs & Stratton generator into that Sol-Ark 15K grid port. We're looking at an outdoor rated Boss 12 cabinet down there for the batteries. And then backing up the main loads panel. Of course, there's only going to be a single loads panel for an off-grid application. Similarly, showing DC coupled. Now, John, my colleague Daniel wanted to get into this one a little bit, and I did as well. I mean, you mentioned it earlier. We're showing a similar example here. I don't have quite as simple of a single line, but notice we're coming out of the grid, going in through our meter, and going through a transfer switch. We also have the 2-wire start that'll start up that generator in a grid down situation. And what our question was is, does the Sol-Ark know the difference between the generator and the grid so that settings will automatically change? How would this work?
So what happens is there is a difference between a generator feed and a grid feed, and there's been a few another question about generator frequency and following the system frequency. The source, the grid or the generator sets the frequency of the grid. And when you have a very large source like the size of the Mississippi River, your little small solar array can't impact it. When you have a source that is about the same size as your inverter, well, then backfeeding that source will impact things like the frequency or the voltage of the supply. And so when the Sol-Ark is used in this configuration, where you're utilizing a stationary generator with a generator's third external transfer switch, what will happen is while the inverter does not have like a contact or a relay to detect grid status, what it does is it'll detect the fluctuation of the grid voltage if it starts to sell back to the grid and say, "Oh, I'm backfeeding a generator. I need to stop that."
That's
Um,
exactly what I was going to ask you. I mean, when we would do a system like this with a generator connected, you've got solar power producing at the same time. Uh, we would use a lockout module or something so we don't fry the generator. But you're saying that the Sol-Ark is smart enough to realize the difference and prevent
it
that with the software.
it is, but there are exceptions. Very large generators, such as sometimes we're using the 15K and three-phase configurations. Those very large generators can overpower the system and therefore keep getting backfed. Ironically, the other example would be ultra premium generators. And so I'm not as familiar with the Briggs and Stratton line, but for example, Generac has a EcoGen line that has an incredibly clean grid signal, and then it shows up as grid power. So I would recommend to installers to try and avoid the situation of backfeeding through other ways. And the first is, accept that, well, maybe the gen port will clip at 19 kW, but go ahead and land the 22 or 24 kW generator on the gen port anyway in a grid tied setting. Or if you have to use that gen port for something else, then when you have external generator controls, to only program the generator to run during your non-solar hours. Where designers start to get into trouble is when they are stacking multiple inverters, such as in luxury home design, and then putting the generator on the grid side and wanting to use the generator with peak shaving so they can run the generator to power non-backup panels and try and treat it almost like a commercial site. It at that point uh, doesn't always work.
But John,
So
wouldn't the inverter itself know through the two-wire start signal that it has started up the generator in the event that those batteries are low and it needs that power?
uh, complicated systems are complicated. It's not so much that the generator isn't starting up to charge, it's that you also have a large, say AC coupled source trying to backfeed the load, and you're not implementing a load sink or anything to have that surplus power be managed. So it really is gets into issue when you do microinverters with generator design, needing to put the generator for one reason or other onto the grid side of the inverter.
I've got a
And
question that's come
this
in
is
for
where
you, John.
sure.
Sorry to cut you off, but the question comes in. It says, is it correct that under the Sol-Ark design, when the system acts as a microgrid, the controller sets the system frequency and the generator follows the system frequency? And under this design, you could have a 6 kilowatt generator with 20 kilowatt hours of batteries.
Like I think that it makes a lot of sense to have a portable generator or a manual start generator process to avoid all of these design considerations entirely. I mean, I know we want to give our customers everything, but it's like, well, do you really want to automate when you've already got in an automatic home energy backup system? Do you want to automate the additional step of having the generator turn on automatically? I mean, I think that uh, there's a pragmatism to say when the batteries drain all the way down to their minimum state of charge, even though you have a battery and a solar generation station already on site, if you still run out of juice, require the customer to press a button just so that they know what they're doing. They're not going to learn anything about their system until they press that button. So try not to over automate everything. And I say this because Sol-Ark has had tremendous generator experience going back to the 8K in 2018. So we've refined the generator controls as much as they can be refined. And don't go into it lightly. Sign up for the Sol-Ark training portal, go through our courses, and understand what is one feature too far when designing with microinverters, generators, smart loads, and a partridge in a pear tree.
And we'll get into generators a little bit farther down. I'm sure that we might not get through all of our slides today. It's great to have John on here and have him be able to talk through some of this. I did want to highlight as well, when we were talking about the 15K earlier, it does have 3 different MPPT inputs, the capability of paralleling there as well. So 6 different connections for your solar. That gives you the east array, the south array, the west array. And John had mentioned how you can build very large systems with these Sol-Arks. In fact, you can parallel up to 12 of these. So very, very easy to parallel these. I'm going to skip through this slide,
Nathan,
but just
to answer that question, yes, you can use a small generator. You can do a 6 kilowatt generator. I think it makes a world of sense to, it sounds like that information they had was not correct about other generators and other systems.
I'm going to mention here just briefly on sizing, right? So if you are sizing this and you're using one of our communicating batteries, but you don't have enough batteries on your system, there are power output limitations to batteries. Our previous batteries were all rated at C/2. I mentioned the ability of a single 6.6 battery to discharge, at 1 C, which is in 1 hour. So batteries have power limitations in addition to capacity limitations. Everybody thinks of the battery and how much overall capacity it has, how much energy is there, but there's also power output limitations. So if you're using one of the smaller communicating batteries, but you only have, let's say, 4 batteries for a 15K, well, the limitations on those battery outputs are probably going to limit your overall power that you can pull from the DC bus, which would limit the amount of power that Sol-Ark is going to be able to output. So you might, if you don't have a large enough battery bank, you might not be able to support the loads that you're hoping to. I point out the 6.6 stacks here, that a single stack is nicely paired to meet the full power requirements of a Sol-Ark 15K. Of course, if you want longer duration backup times, you can use dual stacks. And one of the nice things about the 15K is you have dual battery inputs. And those dual battery inputs allow you to make 2 battery connections. And that means you can use the 15K essentially as your combiner if you're doing 2 stacks. And if you're doing a single stack, we actually recommend using dual 1/0 cabling from that single stack. So double lug at the battery and come out through 2 1/0 connections, one into each of those battery inputs on the 15K. Again, just highlighting how simple it is to install the 15K as compared to other inverters, where if you're using 2 sets of batteries, you're going to have a combiner, an external combiner. If you're doing large systems, you might need a combiner. I'm showing the 1000 amp Midnight combiner in the top left. And on the right side of the screen, if you're going to do multiple inverters, multiple batteries, you are going to have a combiner if you're going for more than 2 stacks. Additionally, you will need to have a single gateway for those stacks, and you'll want to have overcurrent protection on that cabling. Jeff says, FYI, and this is a question for you, I believe, John, FYI, all generators rely on frequency feedback to determine the 60 hertz line frequency. This manages the RPM speed control, of course. Without this, the generator cannot maintain proper output voltage. Without this feedback, the generator will have unstable, unusable output power and then shut down. And of course, it's certainly capable to overload a generator, have that frequency go down as that motor is struggling to turn under the heavy AC load. So thank you, Jeff, for sharing that with us. Looking at a much larger bank here, and in this configuration, we've got two Sol-Ark 15Ks that are paired, and these paired 15Ks are going to need to be combined. So if you've got a 400 amp service, you're going to need to run out of those 15Ks, parallel those connections through an AC combiner in order to support the loads of the home. Also showing you here what are our Boss 12 cabinets. These are 48 kilowatt hour banks, and we've got two of them as well, and we've got a DC combiner on the other side of things. One of the nice things that you can use is power distribution blocks to do the combining. And so if you're coming out of the loads on those 15Ks, you can come in through a power distribution blocks to share the neutrals and share leg 1 and leg 2 of the 240 connection. So it was highlighting those in the bottom right-hand corner. In the interest of time, I'm going to skip through this one. Here's a nice example. This is with Sol-Ark 12Ks. But a nice example of the Phi batteries being used with paralleled inverters there. And as well, using that wire way below, the Sol-Ark 12K used to have their air intake on the sides. Point out that the 15Ks had the air intake on the bottom. And so that means you can space these closely together. I believe, John, is it 6 inches between Sol-Ark 15Ks on the sides if you're paralleling them?
Yeah, you want to have enough to stick your hand and be able to turn that solar disconnect on the side of the inverter, which gets you out of the need for a inline solar disconnect. But yeah, you do need to stick your hands in there. And then another note, there are advanced features, design features on these inverters that installers just don't know about. Things like the fan control and where that air intake, how it impacts the inverter, if it's isolated from the control boards or not isolated from the control boards. Will you be getting humidity and dust into the internals of the inverter by using the fans or not? The Sol-Ark system is isolated and sealed up, and we have thousands of these systems, many of them in Puerto Rico, which is a very harsh environment with zero corrosion issues.
So I have a question for you, John. I've often wondered, people will ask us, what kind of routine maintenance should we do for batteries? What kind of routine maintenance should we do for inverters? Is it a good practice to take maybe compressed air and blow through those fan systems, or could that damage the units?
I don't think you really need to do that with a Sol-Ark unit, because the air system is for cooling, but it doesn't blow air through the internal
Understood that it's isolated on the back.
Yeah.
Okay, in the interest of time, I'm going to keep going. I did want to highlight that for large systems, and I'm showing the installers here who submitted these to us. For large systems, both of these systems have, I believe, 7 Sol-Ark 15K inverters. It looks like those might be 12Ks on the left picture, but for large systems, it might be easier to use big bus bars and combine the batteries in a big DC combiner. And of course, when you're using multiple inverters, you want to have a single bank powering all of them. So you need that combiner. And so showing you some nice examples there with the big Sol-Ark installations. Let's talk just a little bit about the wiring of a Sol-Ark 15K. Of course, you can find most of this in the manual, but I do want to highlight that if you only use one of these sets of breakers, so you've got 2 positives on the left, 2 negatives on the right, the Sol-Ark is going to limit your overall power. Is that correct, John?
Yeah, that's correct. You'll see that they both have these 200 amp breakers on each input protecting it, and so you can't get 275 amps off of one port. You need both ports to get the full backup capability.
Now I'm pointing out the paralleling comms connections there. If you're going to parallel multiple Sol-Ark inverters, you're going to daisy chain from one inverter to the next and then back to the first one. The CAN bus port for the batteries, where you would connect that SimpliPhi 6.6 battery stack, you just have a single battery home run coming to this CAN bus port here to have communications. Of course, the gen port that we've been talking about is here on the left. You've got your neutral bar at the bottom and then your grounding bar just above that. And then this load with your 200 amp load breaker there coming out in the middle. And then this connection on the right side is the grid port. I'm going to point out closed loop communications. I just talked about it, but with batteries. So if you're using any of our communicating batteries, you're going to want to make sure that you have a terminating resistor in a battery that has an empty CAN bus port. You never want to have a floating CAN bus port there. You need that resistor to let it know it's the end of the daisy chain. So you'll fill all the ports of those batteries, of the CAN bus sides of the batteries, those RJ45 ports. So don't throw out that bag that comes with the cable, even if you have your own. And so you'll have a terminating resistor like that. You go battery to battery, battery to battery. And then from that final battery stack, you would go to the inverter. Now, I do point out that on our 6.6 batteries, all of the communications, all of the power connections for each of those modules, those 3 modules that stack on top of each other, all of that's done through that rapid stack technology, in which it's simply a stacked up electrical connection. I don't think there's time really to go through all of the communications pins that are here, but I do highlight that pins 7 and 8 can be used for that 2-wire start if you're integrating this with a generator. And in terms of integrating an inverter with a generator, we've had the most success of any with Sol-Arks, right? Sol-Arks are really good at managing generators and battery charging and auto start with our generators. And so if you're trying to make those connections on the control board of the generator, it's pin 4 and 5 on that 26K, and then 4 and 5 I'm showing you there on the 13K power protect. I'm going to skip through this. In pointing out that there's one thing that I would say, and that's pins 15 and 16 for your rapid shutdown supply. That is pretty limited power there, and so I think that the only one that works with is it the
It's almost always, if you're doing optimizers or monitoring with your rapid shutdown, you're going to use the external power supply
option,
system
yes,
for that.
yep.
Yeah, so
Okay.
it's all like the AP systems rapid shutdown only devices that can take their power directly from the inverter board.
Okay, and so I mean, it's worth knowing, if you have AP systems rapid shutdown, you can pull the power from pins 15 and 16. Just highlighting here, when you're installing the 15K, if you haven't done it before, using a 12 by 12 wireway gives you a number of options to do different things, such as using power distribution boards inside that wireway to act as combiners. You do need to have at least 6 inches of space below the 15K. The fans are right down there at the bottom at the same height as the bottom of the electrical panel for the connection. So you've got to have 6 inches of space there. We're just getting it. And I am pointing out here in the top right that if you want a template, this template is from Practical Preppers. And this template just shows you where to put your knockouts. It's worth talking a little bit about battery programming. I know we're very short on time, and I will stop a few minutes early just to do questions and answers in case people have questions. When you are doing battery setup, it's relatively easy, because if you have a communicating battery like this, like the Briggs & Stratton SimpliPhi batteries, you can simply check that BMS box there, and almost all of the settings are going to be auto-populated for you. Now, you do need to choose what options you want in order to set for charging. So you can have a generator do charging. You can have the batteries charge off grid. You might want to only limit your batteries to charging off of solar, and so you wouldn't check either of those if that's the case. It's also worth pointing out that there is a resistance calculation that you do to put into the Sol-Ark 15K. And I'm highlighting what that is. So you might have your low battery cutout set at, let's say, 48 volts. But you might notice that when you're powering a lot of loads, that the inverter will keep drawing from your battery, even though you're below 48 volts. You might be at 47 or 46. And the reason for that is when you're drawing at heavy loads, you're actually losing some voltage across the resistance of the batteries. And the inverter is smart enough to calculate that voltage drop based on this resistance. I do point out it is a bit dependent on temperature. And so this is not a dynamic value, but it certainly helps take into consideration some of the drops in the batteries. I'll take a second and jump into the questions. Is there a minimum size of SimpliPhi battery or batteries to be compatible with a Sol-Ark 15K? As long as you're using communicating batteries, Ben, you could use just a single or a couple of the communicating batteries. But if that battery bank is too small, you're going to limit the power capabilities of the Sol-Ark 15K. So if you're using an AmpliPhi battery, for instance, you would need a minimum of 7 to take advantage of the full 12 kilowatts of power you can get from the 15K. Or if you're using the 6.6 batteries, you would need 3 of them. There's a lot more power output capabilities for them. So thank you for the question. And I do have that in the slides. We'll get those slides sent out to you after the talk. Mike asks, what about overcurrent protection? Is this required on and off common DC bus bars when multiple inverters are used? Correct. And yeah, the answer is overcurrent protection. If you're using a combiner, so there is overcurrent protection built into the Sol-Ark 15K. You've got 200 amp breakers there. But if you're doing large banks of batteries, you would want and a combiner, like you're using 1,000 amp midnight combiner, you would want to have overcurrent protection on each of those battery cables. And Russell asks, please don't cut John off when he's talking. All right, thank you. And I'll let John answer the other questions. So let's give a chance to have John come in and go ahead and ask questions for John at this time. We've just got a few minutes left.
So I would say on a couple of things is on one, when you have the restart at 31%, I would come into these time of use settings and overnight have a grid charge set at 32%, so that the battery goes all the way down to 32% and does a maintenance charge overnight, keeping the battery at 32%. If you programmed a 31% start percentage, it'll charge the batteries up mostly full if you hit it. So you can avoid that start percentage by programming time of use. It's a seasonal controller, so you get a summer and winter season with that. And as far as providing the fuses when you're combining multiple inverters or multiple batteries, what I would argue to inspectors is that, look, this is a listed system for multiple inverters in parallel. It is Sol-Arks have a UL 1741 CRD power control system, which technically applies to the AC bus bar monitoring and control, but it is monitoring current along the bus. The reason why you fuse DC bus bars when combining multiple batteries together, given that both the battery BMSs and the inverters have, overcurrent protection already built into them in some way, shape, or form, is mainly that the combining point has such a short potential that you have to throttle down the interrupt rating. Your millisecond short circuit interrupt rating can overwhelm the bus bar terminals. So only when you have like 100 kilowatt hour plus battery banks, you end up really fusing the DC bus bar to keep the short circuit current interrupt rating to be within tolerance at whatever the terminals are, 10 kVA or 50 kVA, whatever, depends on what wiring method you're using.
John, you've got another one here. John, regarding whole home backup with a 15K, is it suggested practice to install an MTS in the unlikely event of Sol-Ark failure, primarily to avoid urgent service calls?
It depends. I mean, if you're looking at putting in a manual throw switch, then you may have to figure out overcurrent protection in that line. I think what is more pragmatic. This used to be, sometimes this is called a Hawaiian tie-in, or but it's not really the traditional definition of a Hawaiian tie-in. But basically, on the grid side, my favorite budget way to get over this aspect is to put in a double lug off the grid side and pull a circuit onto a generator interlock switch at the top of your service panel. And that will give you 40 amps or 60 amps, whatever the size of the manual throw switch of the generator interlock is, for servicing. And that will give you power while the system is offline. Granted, you'd have to stay within the limitations of the system. Given how rare that it is that you would have a Sol-Ark failure and the Sol-Ark failure take out the grid connection, and this is true of any type of system architecture, period, that grid connection point could fail, the only way around that scenario is a second grid connection point. And so at that point, it's how much money do you want to put into it? Do we have installers putting in 200 amp manual throw switches? Yes. Do most of our installers do that? No. So I'd say, a middle ground between a $2,500 200 amp manual throw switch and nothing at all is to double lug, maybe even off the external disconnect, and land a generator interlock on top of the main service panel.
Damon asks, and I think this is the last question we have time for. I did put contact information there. Damon asks, in off-grid systems containing BMS, solar, and generators, are there applications that would require CTs? From the manuals, it appears this is only necessary with grid-tied systems. Thanks.
Sure. I recommend installing the CTs anyway. They simply improve the accuracy of the monitoring. So might as well just make it uniform and always install them. For more details on Sol-Ark, you can always go to solark.com and go under training and register in our training portal. And for Briggs & Stratton, Nathan, I'll let you do that.
Yeah, the same. We have our Power Academy as well, and you can reach out to us at energystoragetraining@basco.com. If you are here for those continuing education credits from NABCEP, email the Basco address, the energystoragetraining@basco.com, and we'll get your certificates issued. Thank you, everyone, for joining us, and thank you especially, John, to you for joining us on this webinar. We'll look forward to the next one.
Thank you.